remote file inclusion vulnerability, and we're going to develop some small exploit. Yeah, you can call it uh, proof of concept exploit. First off, let's talk about what remote file inclusion vulnerability is. It's a critical web vulnerability that allows an attacker to inject and execute external code by including remote files from remote servers. Now, this could lead to remote code execution, server takeover, sensitive data exposure, and malware injection as well. Now, on the PinewoodStore app web application, vulnerable web application, I introduced a controller, a Java controller that has remote file inclusion vulnerability. Basically, what it does is there's a controller, it actually loads up a jar file and executes a jar file um, from local. Jar file from local using the URL, and you can actually redirect that because it doesn't have any input validation. As you can see here, I'm not using any input validation to demonstrate this vulnerability. You can use that to inject a remote jar instead of uh, local safe jar. Now, what the program does is actually it uses a jar file, a simple jar file that processes a string, like non-malicious. But sometimes in a situation like that, if a program needs to do that, uh, there needs to be some kind of protection. So attackers can't use that. First of all, it shouldn't even be exposed to any kind of user input manipulation techniques to execute any kind of jar. That should be executed in the back end. It shouldn't even be like visible to the front end. Now, this is a code. Like I said, what is the problem with the code? It accepts unvalidated URLs and downloads and executes the remote jar, and no security controls, allows execution of local files. Now, the proof of concept that I created, the exploit, it's a simple exploit. It uses one class, there's only one class, public Java class. Obviously, if you only have one class, you need to list the main method in there, public static void main. And it's going to use a process builder library. And it's going to create a new process. As you can see, it's instantiating new process. And this process is just going to open up the calculator on the Ubuntu machine just to show that this is actually executed. This is a proof of concept. I think this is kind of like, it's just going to illustrate that remote code execution is possible without doing any damage. So after you instantiate the process builder and you just start the process, and that actually opens up the calculator. And this is just trying to catch block, uh, just in case if you have any errors. Now the next thing you do is just like, obviously it needs to be compiled. And you can do it from your command prompt, java c park1.java. That would compile it. After it's compiled, you need to make it executable jar. And it's just gonna be one line. You're gonna use the jar command, create. C stands for create, F stands for the file name, E for entry point. What it specifies is C is just create a jar file called park1.jar. F is just specifying this is going to be the file name. And E is the entry point. Each time you run this command, you need to let the Java know where is the entry point. Entry point means in Java, when you create a Java program, the compiler has to know where to start processing your code. And the way you specify it is actually one of your classes that you, in Java, obviously everything is a class. So one of your classes needs to have the main method. So that's what is called entry point. So you need to let it know where the entry point, the class that has an entry point. In this case, I only have one class, right? It's just going to be park1. That's why park1.class. And the other thing is, I know a process builder. It's part of java.lang, so you don't need a separate import statement for it. So you just need the IO exception import statement. So it will compile and everything. So Now that we demonstrated that, the next thing we're just gonna go ahead and run it. But what I'm gonna do is actually I'm just gonna run it from I'll create a simple Python HTTP server and I'll serve it from that. Obviously, this is what it is highlighting here, but that's what I'm going to do. I'm going to put that file in my local machine. The machine we're going to attack is going to be on it is already on a VM, Ubuntu VM. So that's what we're going to do it. Now the first thing is let's see where the vulnerability lies. So let me log in. All right, the message board. Now the vulnerability is here. Let me go ahead so we can see it better. Clear history. I'm intercepted. So when you hit the like button, what it does is actually it executes a jar file, as you can see here. Let me send it to repeater. So what we're gonna do, we're gonna try to force it and go out and load a remote jar. In our case, our proof of concept jar. So let me go ahead and drop this. We don't need it because it's just yeah, we're gonna have this point to our local jar. So basically that's gonna be the entry point, and I already created and compiled. Everything is ready. So let's go ahead and execute it and look at the demo. So first, let's go ahead and see the application is running. I mean, obviously it's running because we can access it from the browser. The application is running. It doesn't have any. Currently, we don't have any calculator open. So, all right, let's minimize it. Let's create our HTTP server. Now I put here is my proof of concept jar that is going to execute and open up the calculator in POC2. So let's go ahead and open CMD here. Let's use port 5000. All right. So now if I actually try to see if I can access it. First, let's try it. Let's make sure I can access POC2. So the way I would test it is I can probably use, let's use this browser. So I'm going to use my IP address. My IP address is, I believe, 270, 230. So uh, 5000. So if it's serving it, it's probably going to download it. Let's make sure. As you can see, it downloaded. So the the HTTP server is working. And also, if we take a look at it, you see POC2 GET request. So that's what we're going to use. We're going to use this. And let's go back to And this is going to demonstrate kind of like the same way. Think of it, this HTTP server as an attacker.com, attacker controlled server. So it's serving this proof of concept jar. Obviously, we need to URL encode it. And let's check one more time. All right, see, open up. And you can also see it on the back to process it. I downloaded it here. As you can see here, the application downloaded it and saved it to a temp jar and executed it. That's why. So this demonstrates that the application has remote file inclusion vulnerability, and it downloaded and executed a jar. And also, it will come up eventually here, the response showing, because I'm holding it here, response showing. It executed a jar. Yep. All right, so that actually demonstrates the vulnerability, the remote file inclusion vulnerability, and it also shows that the proof of concept exploit worked as planned. All right, thank you for watching.